Okay, what I was saying that I'm going to do a multiplication. Let's say you're given A plus BI multiplied by C plus DI. So now this is how we multiply. You multiply A with C, A with DI, you multiply this term with that one, you multiply this one with that one. So you end up with A, C plus A, DI plus A, DI. Now you multiply these two, it's going to be plus B, C, I, and the last one is going to be plus B, DI squared. Okay, which is equivalent to AC plus ADI plus BCI, and here we have minus BD. So now we group the like terms, we group the real parts together and the imaginary parts together. We have A, C minus B, D in bracket, these are the real parts, plus A, D plus BC. I. Now we are done with the multiplication here. Since we know that I squared is equals to minus 1. So this explains the concept why I have put minus 1 there. Since I squared is equals to minus 1. So this is basically the multiplication. Now let's take an example to explain the concept. Let's say you are given, let's say Z1 equals to 3 plus 2i, and Z2 is equals to 4 minus 5i. So now you are required to determine Z1 multiplied by Z2. This is equals to 3 plus 2i multiplied by 4 minus 5i. This is equivalent to, if you're a clever student, you can actually just substitute directly on this one, or you can just compute. You can just let 3 to be A, 2 to be B, and 4 to be C, and minus 5 to be your D. Then you substitute to get the answer. So let's do it step by step. We have 12 minus 15i plus 8i minus 10i squared. Now this is equivalent to 12 minus 15i plus 8i plus 10. Now this is equals to 22 minus 7i. So this gives you a solution. So we have multiplied these two complex numbers. Now, immediately after doing complex numbers, something comes to your mind. The next thing, it must be a division. Before we can do division, let's go through this concept of a complex conjugate. What is a complex conjugate? Because for division, we'll need a conjugate. Okay. Now, the next thing that I'm going to discuss is what we call complex conjugate. So if you are given a complex number z1 equals to a plus bi, the conjugate of this complex, denoted by this, is equals to a minus bi. So a minus bi is a conjugate of a plus bi. Okay, so that's basically conjugate. That's what I wanted to discuss. Okay, now let's see what happens if you multiply these two. Z1 multiplied by its conjugate. What will be the solution? So we have a plus bi multiplied by a minus bi. So let's multiply. We have a squared minus abi plus abi minus b squared I squared. So this is equivalent to, you can clearly see that these two guys are like terms. They will get rid of each other. So we have a squared plus b squared. Okay, we know that since we know that I squared is equals minus 1. So this gives us that answer. Okay, so if you multiply a conjugate as a complex by its conjugate, your answer will be a squared plus b squared. Okay. Now I think we are ready for the next topic, which we call not topic, section, division. Division of complex numbers. Complex numbers. Okay, this one will be easy to use example. So let's say we have 2 minus 5i all over 3 plus 4i. This is equivalent to 2 minus 5i all over 3 plus 4i multiplied by a conjugate of a denominator. So the conjugate of the denominator is 3 minus 4i over 3 minus 4i. So here I didn't change the expression. I actually multiplied the expression by 1. So if you multiply anything by 1, you know that it will remain unchanged. So I'm just introducing this conjugate over conjugate to help me to simplify this expression. So this is equivalent to, now we know how we multiply. I'll just show you on top. We'll multiply these two, multiply this one with that one, this guy here with this one, and that one with the last term. So multiply like that, we have 6. Let me change, I prefer the dark color. So it will be 6 minus 8i minus 15i plus 20i squared. Now we'll do the same on the denominator. So you'll end up with 9 multiplying the same way, minus 12i plus 12i plus minus 16i squared. Okay, so this is equivalent to, now we look for like terms. So we have 6 minus 13i minus 20 all over. Now these two can check they are the same, so they'll get rid of each other. Now we have 9 minus 16, so it's 9 minus 16 minus 16. So here we have used, we know that I squared is equals to minus 1. That's what has changed our expression. This is equivalent to 6 minus 20. This will give me minus 14 minus 13i. Okay. Okay, I'm just checking if I have made a mistake. All over 25. You should always write your solution in the form of a plus bi. So this will be minus 14 over 25 minus 13 over 25 I. So we end here. So we have divided those two problems. Okay, so this is basically how you do division of complex numbers. Okay.
Say,
hello,
what did you multiply by 1, like a top?
Is it not minus 1?
It's 1.
Wait.
I mean, 3 minus 4i divided by 3 minus 4i, it's 1. Why did you multiply by 1?
Okay, which step? Let's start. I'll put the name so that I'll understand where your question is. So we have step 1 here, step 2, step 3, step 4, and 5. So your question is on step what?
The first one.
The first one.
Yeah, where you multiplied. Yeah.
I multiplied 2 by 3. It gives me 6. I multiplied 2 by minus 4i. It gives me minus.
I want to know the reason. I want to know the reason why you're multiplying that thing.
Okay. Why am I multiplying? No. This process is called, when we're dealing with square roots on the limits, we said we rationalize. It's the same process as rationalizing.
Oh.
Yeah, we are rationalizing this problem.
Then what is this thing of since I squared is equal to minus 1?
This means you didn't attend the previous class.
Yeah, because the recordings are not there, say.
I'm not talking about the recordings. They didn't say that you should look for recordings. They said that attend classes. Did you attend the previous class?
Yes, I did. That one when you're proving that the square root of minus number does exist.
The square root of, actually, we started with a quadratic equation.
Yes.
And then we solved a quadratic equation.
Yes, I was there.
And then with the quadratic equation, when you were in high school, the square. We said that if we have a negative number within a square root, then the solution will be imaginary or non-real. Now here, when you enter this level, instead of saying that the solution is non-real, we introduce another system of numbers, which is called complex numbers. Complex numbers consist of real numbers plus imaginary numbers. Okay?
Yes.
Now, so let's say we have x squared plus 1 equals to 0. So x here is equals to what? X squared is equals to minus 1. So you take the square root on both sides. So you have x equals to plus or minus the square root of minus 1. Now, the mathematicians, they have actually let the square root of minus 1 to be equals to I, and other books they are using J. That's what I said. So I'll accept both. So this means the solution actually here we have x equals to plus or minus I. Now, if you square minus 1 equals to I, you square both sides. You square this side and that side. We end up with I squared equals to minus 1. That's the way the concept comes from. I hope now it's clear.
Yes, it's clear, sir. But then, sir, may you please upload the slides for odd and even function and also for complex numbers so that we can practice on our own?
Which slides? The one that I was using.
Yeah, even the one for odds and even functions. May you please upload them because we don't have resources.
Okay, I'll do that. I think it'll be easy when I'm in the office. Okay, is it okay now? I'll upload them. Sir. Even the videos, I'll try to upload what I have.
Everything, saving the solution for the limits.
Which solution for limits?
Yes, everything. We need everything.
Which solution?
The
The
ones
limits,
which,
the limits.
yes, everything.
Which
Sir.
one?
The
I
one,
don't have solution.
the one which you did.
I didn't have solution. I lectured on limits.
That
Not
slide on the first page has it's only questions, like there are no solutions. The one which you did with us in class.
yeah,
Like
it's
solution.
a PowerPoint presentation. PowerPoint presentation doesn't have solutions. Solutions, I do them as I present. Okay, I don't have solution where I put them aside. As I teach, I solve those problems, and I don't have solutions. So though, for you to get solution, you must go through the video and go and look for more information from the results. They give you in internet, isn't it? So you can also go there and check. If I provide you with the video, it will be sufficient for you to be able to do the remaining ones that I didn't cover.
Okay, thank you, sir.
Okay, thanks. Okay.
Sir, can we ask about negative 8i and negative 15i? You equals to negative 13i.
No, I wrote 18, supposed to be 23. Yes, I understand your yeah. Supposed to be 23, yeah? It's 23. Okay, thank you also. 23i. Okay, thank you. This shows that at least you're focusing when you start traveling. Okay. So I'm expecting 80% passing rate for the travel I'll go through. Okay. Now, that's what we call equality. Equality of complex numbers. I don't know what happened here. Okay, equality of complex numbers. So in this case, there's nothing that difficult. It's just that you are given two complex. Let's say Z1 equals to A plus BI, and let's say Z2 equals to C plus DI. Okay, A plus BI will be equals to C plus DI if and only if A is equals to C and B is equals to D. Yes, that's all under equality of complex numbers. You are given two complex numbers, and the first one is Z equals to A plus BI, and number two is Z2 equals to C plus DI. So in general, in English, two complex numbers will be equal if their real part are equal and their imaginary part are equal. Basically, that's the case. Okay, this actually helped us to solve complex equations. So next is activities on how to use this complete, let's say, complex equations. So under complex equations, let's say, for instance, one, solve the complex equation or solve for x. solve the complex equations. We are given number 1. This ones I'm going to solve with you, don't worry. 2x plus I, that's the case, equals to 6 minus 3i. So here, well, let me just put number 2 also before I solve. This 1 plus 2i minus 2 minus 3i equals to a plus bi. So here, number 1, let's give the solutions. So SOL, solution for the first one, 2x plus 2i y equals to 6 minus 3i. According to the definition of equality of complex numbers, we have 2x equals to 6 and 2y equals to minus 3. So this means x is equals to 6 divided by 3 equals to 2, and y is equals to minus 3 over 2. So we have solved the problem. Number 2, we have 1 plus 2i minus 2 minus 3i equals to a plus bi. Now here we will use FOIL method. You multiply 1 by minus 2, you get minus 2. 1 by minus 3 minus 3i minus 4i minus 6i squared equals to a plus bi. I group the like terms. Before that, let's get rid of this I squared. We have minus 2 minus 3i minus 4i plus 6 equals to a plus bi. At this point, I think you can see what's going on. Now, the real part, we have 4 minus 7i equals to a plus bi. Now, from here, we equate the real part. We have a is equals to 4, and we equate the imaginary part. B is equals to minus 7. Okay, so this is basically what the equality of complex numbers help us to be able to solve the equations. Okay. So this is the case. Okay. Now, we are still under complexness. Now, the next thing that comes is what we call the polar form of a complex number. So last week we talked about an Argand diagram. Let's start there. What do you understand by the word Argand diagram? So I'm going to plot it again. This is an Argand diagram. On the y-axis we have imaginary numbers, IM, and here we have real numbers, RE. Let's say that our complex number is plotted here from 0 up to a certain point there, which is AB. But in this case, we'll just denote it by Z. So this will be my Z. Now, between the real number, the real number here we have an angle. This angle, let's call it theta. Okay, and it's moving in anti-wise direction. And then here, if we join these two, we have a right angle triangle. So here we have I, let's say this is IY, representing the imaginary. And here we have R, and here we have X. Okay. Now here, you can calculate, I think that's the second thing I have to. We can calculate what we call modulus. Modulus is nothing but, remember that we have there we have Z equals to X plus IY. Now what will be the modulus of Z here? Is equals to the square root of X squared plus Y squared. So that will give you a modulus. And once you have modulus, you must be expecting to have an angle theta, an argument. Here we call it an argument or angle theta. So KRG, that argument, an argument of Z. So you can still write del theta, there's nothing wrong, which is equal to tan inverse of X. So now we determine two things. Our R is modulus. So our R is modulus, which you can call is the absolute value of Z, which is equal to R. So basically the absolute R. Okay? We have seen that when we solve equations, a trigonometric equation, we have seen that this angle of us that we have here, theta, is not unique. It can have more than one value, one in the first quadrant or second quadrant and so on. So now I'll just write here that this angle is not unique. Okay, so in certain questions, they will restrict you. They will ask you to use what we call principal value. So when they ask you to use principal value, they are actually asking you to determine the value between minus pi to pi. And you can clearly see that this value is excluding minus pi but including pi. So you'll determine any angle between minus pi to pi. So the problem that you are going to be solved will be restricted on these values. Okay. So now we have determined what we want. Now, so in polar form, this is how we write our complex. So you have to determine the value of R and you determine the angle theta. So this is complex numbers in polar form. Now let's say, for example, let's do one example to show basically what you have to do to determine. Let's say, for instance, I ask you to write 2 plus 3i in polar form. So what do? You can represent it. I think it always helps. Imaginary real number, so that you can know that this complex is in which quadrant, so that you can give a correct angle if it's in the third quadrant and the fourth quadrant and so on. So you can clearly see that this will be my 2 here, and let's say this is 1, 2, 3. So this is in the first quadrant. Okay, now you have to determine the value of R. R is equals to the square root of 2 squared plus 3 squared, which is equals to the square root of 25 equals to 5. So now we have determined the value of r. Now you have to determine the value of theta. Theta is equals to tan inverse of our y is what? Is 3. Our x is 2. And this is equivalent to 56.31. Okay. Okay. I'm actually checking my mistake here. I can see this is wrong. It's 4 plus 9. This is 13. So I'll ask you also to check the angle if it's correct. Let me check using my calculator just to verify. So here I'm working in degrees. Tan inverse of 3 over 2. 56.31 is correct. So now using this form here, you start by, this is rotating, this one is out. So rotating is approximately equals to 3.606. So our in polar form, this will be 3.606, and then you write the angle is 56.31 degree. So we have managed to write our angle in polar form.
So,
hello?
When you're doing this thing, so I get earlier on in the year when you spoke about angles and all this stuff, you said you're supposed to do it in radians. So these ones were supposed to do it in degrees.
For polar form, you can do both. There's nothing restricting you. You can use degrees and radians. So in this case, I'll accept both answers, degrees and radians. But when you go to exponential form only needs radians only. Okay.
Okay, so is it safe if you just use radians throughout the paper then?
Yeah, it's safe. Yeah, it's safe to use radians across. Yeah.
Okay, thank you, sir.
Okay. Now let's look it again. I'm just trying to. Okay. Basically, if you look at it, you can see that x is actually equals to r cos theta, and y is basically equals to r sin theta. So we can play safe and say that z is basically equals to what? X is actually equals to r in bracket cos theta plus I sin theta. So this is our complex number. Okay. So in polar form, some students, they usually write it in this form, which is still allowed. It's still in polar form, or you can write it directly in that form. Okay. Now, under polar form again, we check multiplication and check division. Okay. Okay. I don't know why they jump subtraction and division, but we usually ask question for multiplication and division. Addition and subtraction will still work out, because if you have two coses, cos theta plus cos theta is 2 cos theta. Okay, so you will be able to add two complex numbers. Okay, now let's look at multiplication. And division. I'm trying not to complicate this thing for us to get knowledge first. The complicated stuff can come later. Okay, Z equals to R1 theta 1, and we are also given Z2 equals to R2 theta 2. Now, when you multiply two complex numbers in polar form, Z1 multiplied by Z2. So this can be multiplication. The dot also means multiplication. So you just multiply R1 by R2. And what do you do to the angles? So this is an angle, and then theta 1 plus theta 2. So this completes the multiplication. Okay, division. We have Z1 divided by Z2. Z1 divided by Z2. So we are going to have R1 divided by R2. Angle, we have theta 1 minus theta 2. And this is division. Okay, in a simplified form actually. So, for instance, if you are given number A, you are given 8, and then the angle is 25 degrees multiplied by 4, 60 degrees. And number B, you are given 3, and the angle is 16 multiplied by 5, and the angle is what? Is minus 44, and then multiplied by 2, and the angle is 18. So solution for the first one, you can clearly see that for number A, you multiply 8 by 4, it's 32, and then the angle is what? They say that we add the angle. If you add them, you get 85. So this will be the solution. Number B, 3 multiplied by 5 is what? It's 15. 15 times 2, 80. And then you check the angle. What do you do to the angles? You add them. So it's 80 minus 44 is 36. 36 plus 16 is what? Is it 52? 52 degrees. We'll verify that. So we can see that it actually helps to know how to multiply and how to divide. So let's look for one way you do division. Given 10, and the angle is 4 pi over 4 actually. Pi over 4 multiplied by 12, and the angle is pi over 2. Everything divided by 6, and the angle is minus pi over 3. So you start by doing what here? What is your solution? We have, this is equivalent to 10 multiplied by 12 divided by 6. Those are your radius. Then you have angle. What do you do to the angle? You have pi over 2, no, pi over 4 plus pi over 2 minus 3 pi over 3. So we can just put this one in bracket, and then does it. And then it's simplified to, is it 20? 20 here. And our angle is what? Our angle is 13 pi over 12. Okay. So 13 pi over 12 in degrees is equivalent to what? No, let's leave the degrees. Okay. So what I wanted to illustrate here is another thing. We said our solution is from minus pi to pi. This is the principal solution. Okay. Now I wanted to locate where is this. This is another way. This is enough. We can stop there. That solution is acceptable. Unless if they ask you to determine maybe the principal solution. So I think it's something like 195. So 360 minus 195, I think that will be where. So let's locate 195. 195, it will be somewhere here, not that far from okay. Now this same solution can be given as 20 pi 11 pi. So just one here, 13 and remember this is our direction. We move anti-clockwise. So if you move in a clockwise direction, this will give you minus 11 pi over 12. So both of them are acceptable. Okay. Now it will depend on what is asked, whether to provide the principal solution or not. Okay. Okay, so when I look at my notes here, the next thing that I have to discuss is the theorem. I don't think it will be advisable to discuss it today. I'll discuss it in the next class. It's called De Moivre's theorem. So this one will use it to determine the powers of a complex number and the roots of the complex numbers. So I'll discuss that in the next class. And after De Moivre's theorem, will deal also with the exponential form of a complex number, and also do something De Moivre's theorem in a complex form. Okay, now I'm going to come back here to stop my class.